Hi. In this problem, we are going to look at a binomial identity where we have a couple of functions that are defined. One is g of m of n, and that is defined in terms of a f function. Basically, it's the summation of p going from 0 to m plus n for f of m and p divided by n plus pcp, where f of m on m and p is defined in this particular way. It's a summation of three combinatorial terms, right? So it is I goes from 0 to p, mci multiplied by n plus I cp multiplied by p plus n cp minus I, right? So finally, we have to basically figure out what is g of m of n, and we have to answer these four statements, which ones are correct, right? So obviously, the way to attempt this problem, you have to start by trying to simplify g of m of n. And in order to do that, you have to understand what f of m and p is, right? So I will try to work from here and I'll try to find out what f of m and p is. So I will just expand each of the combinatorial identities in terms of their factorial definitions. So MCI becomes m factorial by m minus I factorial I factorial. N plus ICP becomes n plus I factorial on top by n plus I minus p factorial and p factorial. And finally, p plus n c p minus I becomes this p plus n factorial by p minus I factorial. And then you subtract p plus n minus p plus I. So it becomes n plus I factorial here. So this is a summation. The summation is over the variable I. And you can easily see that n plus I factorial gets cancelled here, right? N plus I factorial gets cancelled. And let's take out the terms that do not depend on I, right? Summation is over I, and we can take out this p plus n factorial outside, p factorial outside. So I will say p plus n factorial outside and p factorial outside. Why am I not taking out this stuff, the m factorial and all? Because right now I will try to combine those with the remaining terms here. So what I will say is summation I goes from 0 to p. You have m factorial by m minus I factorial. You have n plus I minus p factorial. And you have p minus I factorial. And that's it. This is what you have here. And outside we have p plus n factorial by p factorial. Now, the idea why we had taken out p plus n factorial by p factorial is because if you notice, once you simplify f of m and p, we have to use that in this expression. And there is a f of m and p divided by n plus p cp. N plus p cp is actually p plus n factorial by p factorial n factorial, right? So basically, if I get f of m and p in terms of this stuff, then I can later cancel this out, right? So what I can see is that I can make a n plus pcp here in my expansion of f of m and p by multiplying and dividing up and down by n factorial. So I'll put an n factorial on top here and put it one here down. So this becomes n plus pcp summation of I goes from 0 to p, and this becomes MCI. The first three terms become MCI, and these terms become NCP minus I. If you think about it, this plus this adds up to N, so therefore this is NCP minus I, right? So what is happening is f of m on m and p is coming out to be something like this. It becomes n plus pcp summation over I from 0 to p mci n plus pcp. Here there was an n plus pcp summation over I from 0 to p mci multiplied by ncp minus I, right? Now, if you have seen such types of summations before, you will realize that this expression here on top here, this expression is like a product of coefficients like this, nc0 ncp plus mc1 ncp minus 1 plus mc2 ncp minus 2 and so on till mcp and nc0, right? So this would be coefficient of x power p, because the subscripts are adding up to p in the expansion of 1 plus x power m plus n. Why? You can write 1 plus x power m like this. It will be c0 plus c1x plus c2x square, and so on till cm x power m. And you can write 1 plus x power n like in the opposite order, x plus 1 power n, as c0 x power n plus c1 x power n minus 1, and so on till c0 x power 0, right? No, not c0, cn x power 0. Now, in these two series, if I multiply both sides and keep track of coefficient of x power t, you'll realize that coefficient of x power t will come when I do cm into ncp here. ncp would be x power n. Here the cp term will come what? It will come when you have x power n minus p, right? And so we'll multiply by this term, n minus p term. Okay, n minus p term will not be useful. We'll multiply c of n minus p. C of n minus p x power p term here with the. Okay, I am making a mistake here. We don't need to think like that. What we can say is I need coefficient of x power p in 1 plus x power m plus n. How do I know that? Here, what is the first term? mc0 into ncp. What is the power of that? mc0 comes here, mc0. ncp will come somewhere here, ncp. The power of this would be x power n minus p, right? Correct? ncp, however, can also be written as ncn minus p, and that time the power would be x power p, right? So ncp is equal to ncn minus p, and that time the power will be x power p. So multiply this with this mc0 term. So you're getting x power p. Now mc1 you are going to multiply with ncp minus 1 or ncn minus p plus 1, right? So if you write down the terms, you'll realize that this is coefficient of x power p in the product of these two series. It is obvious. If anybody has doubts about this, I can show it to you in a slightly more detailed video, but I think you can figure it out if you write a few terms. Okay. So this will come out to be basically m plus ncp, right? M plus ncp. So coefficient of x power p in 1 plus x whole power m plus n. So this becomes basically n plus pcp multiplied by m plus ncp, right? Correct. We are getting this expression right now here, and now we know our f of m and p. And if I know f of m and p, I need to find g of mn. G of mn will be f of m and p divided by n plus pcp. So when you divide the n plus pcp, you will end up with only m plus ncp on top, and nothing else is there. And g of mn was the summation from p goes from 0 to m plus n. G of mn was basically summation p goes from 0 to m plus n. And if you realize this expression becomes basically m plus ncp. And that is the sum of all the coefficients, all the combinatorial coefficients of the expansion of 1 plus x power m plus n. That will be 2 power m plus n. That gives you the function g of mn. And that implies that g of mn is equal to g of nm. That implies this also, because m plus n plus 1 is equal to m plus 1 plus n. And that also shows you fourth option. You can check that g of 2m and 2n is equal to g of mn whole square, because the power 2 will get multiplied with the m plus n and will become 2m plus 2n, right? So the answer for this one is A, B, and D, first, second, and fourth option. The idea in the question is basically not to get scared by the look of the problem. The problem looks weird and difficult, but actually you have to simplify this first, f of m and p, and try to ensure that you get n plus p cp common as a factor in f of m and p, so that it gets cancelled here. If you do things carefully, you will realize that g of mn will come out to be 2 power m plus n, right? So that's it for this problem. If you have any doubts in physics and maths, please do use the link in the description to send the doubts to me. I will make a video and try to clarify as many of your doubts as possible. Otherwise, if you like the content in the channel, please think about subscribing to the channel, press the notification icon so that you know when the videos are coming. And hopefully you will learn a lot from the channel. I'm going to continue making the problem solving series. This is like a year-long series, and by the end of this year and probably for JEE 2024, I will have like hundreds of problems which will definitely help you reach a higher level in JEE Advanced. Also, some of these problems are all from old Olympiads, Romanian Olympiads, Chinese Olympiads, and this will also help you for your PRMO and RMO preparation in case some of you are in lower classes and are not thinking about JEE right now. So stay tuned to the channel and like and subscribe to the channel, and I'll see you in the next video.